Hello and welcome to this session where I will be speaking about Java on Graviton and more specifically how to use Corretto, which is the Amazon Java distribution. I'm Arthur Petit-Pierre, a principal specialist SA, helping customers to adopt Graviton-based instances. Before we start talking about Java on Graviton, let's take a step back and speak a little bit about what the Graviton processors are. AWS has released its third generation of Graviton processors, the Graviton 3, and those processors are custom silicon that is designed by AWS using the 64-bit ARM architecture. And we will talk a little bit later about more specifically what is the 64-bit ARM architecture and how it is different from potentially the architecture you're more used to, like the x86 architecture. Those processors have been targetedly optimized for cloud-native workloads, which means that we have ensured that they're finding the right balance between the performance, the cost, and the energy efficiency. Overall, building our own processors at AWS is an initiative, a long-term initiative actually, that allows us to innovate, build, and iterate more rapidly on behalf of our customer with things such as getting feedback on the kind of applications our customers are running and the kind of performance improvement that we can do at the processor level to make them faster. One of the things that customers are often wondering is what are the kind of applications that are easy or more difficult to migrate to Graviton-based instances. I'm not going to cover that entire table today, but things like Java, since this session is about Java, tends to be in the quite easy section of the workloads that you can move to Graviton. When that's running on Linux, using the Java language, it's not a big deal, and I'm going to explain you why. Before I explain you why, let's take another step back and talk about processor architecture. You've probably been using Intel or AMD processors for like the last 15, maybe 20 years. Those processors do use the x86 and the 64-bit version of it, the x86 instruction set. The Graviton processors do not use that exact same instruction set. They use the ARM64 instruction set. And the fact that it's using a different architecture means that when you run applications on ARM64 on Graviton, you need different executables. Okay, but there's a little bit more complexity than that. There are kind of three different types of programming languages. A first type is the interpreted languages, things like a shell script or languages like Python or PHP. You write some source code, there's no compilation step, and when you execute it, you use the interpreter to interpret the source code and generate on the fly machine code that can be executed by the processor. There's a little bit more complexity behind that. Some of the interpreter are actually doing some sort of just-in-time compilation behind the scene before they do execute, but let's make it simple. There's another type of languages that are having an intermediate representation. You write the source code, then you use the language compiler to generate an intermediate representation as bytecode. And then when you need to run that bytecode, you do it through a virtual machine that will on the fly generate machine code for the targeted processor and execute that machine code. Java is in that category. You start from your source code, you use the Java compiler to compile bytecode and assemble a jar file, And that jar file contains bytecode that is architecture independent. You can execute the same bytecode on an x86 system and a Graviton system. The translation is done by the JVM, the virtual machine that I'm mentioning here, before it is executed. Some more complex things might happen behind the scene. There's just-in-time compilation and optimization that is done, but that's the overall idea. And a third type of languages are languages that are directly compiled to machine code. You write the source code, for example, in C or in C++, and once you're done writing that source code, you use the compiler to transform the source code to machine code. And that machine code is almost ready to be executed without any other modification. It's really fast, but it's really machine specific. You have to generate a binary for x86, a different binary for ARM64. It's not portable. Java is pretty nice because you're in the situation in the middle here, and when you compile the application, you generate bytecode that you can execute almost everywhere. Well, everywhere where you can find a JVM. You might wonder, but what happens when I'm using a Java-based application in a container, which is the case for most of you nowadays? So if we take another step back, we are taking a lot of step back today, and look at the overall picture. The overall picture of a container-based application running on AWS, whether that's through services like Fargate, where you just manage the container, or whether you're managing your own orchestrator on top of EC2 instances, behind the scene, that's always the same thing. You have an hypervisor, which is generally managed by AWS, that's offering you the ability to run virtual machines on top. The hypervisor itself is architecture specific. We have a version for Graviton-based instances. We have a version for x86. We share the same source code, but we generate a version for each of the architecture. The next layer is the VM layer. So when you choose to launch an operating system on top of one of our VM, let's say you choose to run Ubuntu or Amazon Linux 2, depending on the target, whether that's Graviton or an Intel or AMD-based instances, you will choose a different architecture. For Graviton, you will choose an AMI for the ARM64 architecture, and they're available for most of the Linux distributions, even FreeBSD and a couple other real-time operating systems. So you will choose an ARM64 version or an x86 version because that layer is architecture specific. With the operating system will come the runtime for your container environment. And that runtime is generally written in a low-level language like Golang, and is compiled and is architecture specific also. On top of that, you will have container instances that are executed from container images. And we'll dig that in the next slide. And then at the very top of it, you will have your application, which depending on the language that it's written in, will be more or less architecture specific. If we zoom into the container instance that is executing on top of that environment, you'll have actually two things. You have what I call the container envelope, so all the environment that is coming with the container image, the libc, for example, that is included, a couple different library that are coming as a dependencies, and that envelope is architecture specific. You need to have a version for ARM64, and you need to have a different version for the x86 architecture. They can come from the same Docker file. You can write it once and generate a version for ARM64, a version for x86, and even store that under the same tag in your favorite container registry. That's called multi-architecture. The application inside, it's going to depend. As I mentioned earlier, if it's an application that is using an interpreter, the application is going to be the same regardless of the underlying architecture. It's just the interpreter that will need to have an ARM64 or an x86 version. If it's a Java application, since we are talking about Java during that session, the bytecode is going to be the same regardless of the underlying execution architecture. You'll just need to choose a container image that will contain an ARM64 version of the JVM for if you want to run this on top of Graviton instances. A really good JVM to run Java on top of Graviton-based instances is Amazon Corretto. Amazon Corretto is a distribution of OpenJDK, which is an open source JVM that is built and maintained and supported by AWS. The reason we've done that is that we have many customers that are running Java application on AWS, and we feel like they deserved to have a well-supported, well-optimized, and long-term supported version of Java on which they could rely on. You can use Amazon Corretto on AWS, but a thing that is less well-known is that you can also use it and get support from AWS if you use it on your development system and even on your on-prem system. We want to make Amazon Corretto a really good JVM that you can run everywhere. And of course, Amazon Corretto is available for Graviton-based instances. We do make optimization that are specific to Graviton. For example, we ensure that the version that we compiled for ARM64 has all the options that are making it fast for Graviton-based instances. As an example, we compile it with large-scale extensions that are a set of really fast atomic operations available on the latest version of the ARM64 architecture that we have on Graviton 2 and Graviton 3 based instances. And that's a difference between Corretto and most of the other build versions of OpenJDK. We also contribute a lot of optimization to OpenJDK that are targeting the ARM64 architecture. And we contribute all those development back to the community to ensure that Amazon Corretto stays as close as possible to OpenJDK. You can use Amazon Corretto as a container image. Here, I give you an example of the screen that you can see if you look for Corretto container images on our ECR public repository. You will find Corretto versions for the different versions of Corretto, starting from JDK 8 up to JDK 19. And there are various flavors for the different architecture, ARM64 and x86, and based on different Linux-based images. You can also use Corretto as a package in your favorite Linux distribution or as a package you can install within your favorite container-based image. For each of the Corretto versions, there's a URL where you will find the place where you can download Corretto from. I put the URL at the bottom of the page. You just have to replace the version by the version you're targeting, like 11 or 17, whatever, and you can directly download the version of Corretto. For Graviton specifically, we have versions recommendation. The minimum version is 8. There's no support for the ARM64 architecture below version 8. So if you have an application that is relying on JDK 8, you can definitely run it on top of Graviton-based instances. Will you get the best performance out of it? Probably not. 8 is a pretty old version now. It predates Graviton by many years. If my memory serves me well, it was released in 2014, whereas Graviton 2 was released in 2019. So it's not as optimized as it could be. We recommend customers to use at minimum JDK 11. That's the version that will start to bring you better performance. If you can use a more recent version than that, like JDK 15 or JDK 17, that's even better. Actually, that's a general recommendation when you're adopting the Graviton processors. The more recent the version, the better it tends to be. The reason is that the architecture we are using with the Graviton 2 and Graviton 3 processors is pretty recent. Remember, we've released Graviton 2 in 2019, so only the really recent versions of software have had the time to be optimized for those processors. How to install Amazon Corretto on Linux? You have many options here. I've listed two. One is to use the native package management system. So if you have a Debian-based distribution like Ubuntu or Debian itself, you can execute the instructions that are at the top here, adding first a repository to your list of repository, updating the metadata associated to that repository, and then use apt-get install to install the version of your choice. I've listed the 11th version here, but that you could use 15 or 17 if that's what you run on. On RPM-based distributions like Amazon Linux or Red Hat or CentOS, you can use the same method, but this time with RPM and yum, first installing the repository, updating the metadata, and finally installing the Corretto package using yum. All those instructions are available on our website. The URL is at the bottom of the screen. Just replace version with the version of Corretto you are targeting, and you will get the full version, the full instructions to install Corretto on Linux. You might wonder whether you need to tune your JVM in a specific way for Graviton-based instances. Well, there are actually very few things that you really have to do. Usually at the JVM level, you tune the garbage collector behavior, and that's more of a tuning that depends on your application rather than on the underlying processor. The JVM is providing you with a pretty decent abstraction layer with regards to the underlying processor. There are still a couple tunables that you may need to apply. We list all of them on that page. And there's one particularly important thing that I would love you to know about running Java-based application on top of Graviton. Some Java libraries and applications do have extensions written in low-level languages like C or C++ and compile directly into native code. Those extensions are called GNI, and they might be embedded into your application or one of the jars you depend on. If that's the case, when running application on Graviton, please ensure that those dependencies have a version of those GNI modules that has been compiled for the ARM64 architecture. Otherwise, it would fall back to a Java version that's probably going to be slower than the native version. On that page, we provide you with a set of scripts that are able to analyze your jar files and find out whether you have such GNI extensions and whether they offer an ARM64 version. So don't hesitate to check there. Finally, if you have any question about Graviton in general, like operating system versions that you should use, or guidance on how to do performance analysis on top of Graviton-based instances. We have assembled a technical guide that is available on GitHub. The URL is at the top of your screen. Please have a look. We are updating it on a regular basis. And if there's anything that would be missing in that guide, please open an issue, leave us a comment, and we will do our best to give you an answer. If you want to send us an email asking a question, you can send it to ec2-arm-dev-feedback@amazon.com. There's a team of solutions architect and software engineers that are listening to that address, and we will give you some feedback and some answers. Thanks a lot for listening, and I wish you a happy Graviton adoption. Have a nice day.